Hi everybody! In this video I'm going to talk about reform, solving log and exponential equations. Okay, so basically, you're going to be solving for x, just like you've always done. But you're going to have to use your properties, whether it be rewriting as an exponential, rewriting as logs, taking the natural logs of both sides, or taking logs of both sides, using your power rule, using your product rule, using whatever properties you absolutely can in order to get x by itself. So in this case, I'm just going to run through some examples for you guys, and hopefully you'll be able to catch it on, see why I'm doing what I'm doing. I notice that I have an x in my exponent. Well, dang, I can't just divide e, I can't subtract e. We're going to have to do something to figure out how to get this exponent, x, down to how we normally are seeing, like x equals something or whatever. It's x equals monkey. How about that? Red monkey. It's a orangutan, red orangutan, rare red orangutan. So if we want to solve for x, well, I know that I would at least need to subtract 5 from both sides, so that I have e to the x equals 55. And then by our power rule, that's the only way that I know to get this out of the exponent. So if I take the natural log of both sides, then I can use my power rule to pull that x in front of your natural log, so that we would have x natural log e equals natural log 55. You can take the log or the natural log, it won't make a difference. I always take the natural log just because it's shorter to write, because there's only 2 letters instead of 3. Really, that's why I do it in most cases. However, in this case, since I have a base of e on my natural log, e, so it's to the exponent, which is 1, so that kind of just goes away. So I have x equals ln 55, which when you plug it in the calculator, x equals 4. James Bond. Okay, good. X is by itself. We solved for it, plugged in our calculator. We got a decimal answer. Perfect. Awesome. You guys are great. Okay, in this one, and in any of these problems, really, there's lots of different ways that you can do these things, as long as it makes mathematical sense. If you wanted, you can take the log of both sides right now and use your power rule, your product rule to break up the multiplication. However, I know I'm going to have to break up this multiplication right here anyways. So if I just go ahead and divide by 3, then I'm going to have 2 to the x equals 42 divided by 3 is, oh, come on. There we go, 14. All right. So now that I have, again, just like in the last one, my x is in my exponent. The only way that I know how to get rid of that is if I had a natural log. So what I do to one side, I must do to the other. This allows me to use my power rule and bring that up front so that I have x ln 2 equals natural log 14. And then this ln 2 is just like any other number. It's as if it was 3 or 4 or 15 or 29 or whatever. Right now it is multiplying the x. So in order to undo multiplication, we divide. Oh, that's a 2. So that makes 1. And we're left with x equals ln 14 over natural log 2. Plug it in your calculator just like that, and you'll come out with something like 3.807. Hopefully. Cool? Bananas, awesome, pineapples. Here's a different type of problem. Okay, I have log on one side, I do not have a log on the other, so I can't really just say x minus 2 equals 2. However, by using our rewriting as an exponential, I can say 7 squared equals the thing inside, so equals x minus 2. I know 7 squared is 49 equals x minus 2. And then if I add 2 to both sides, there it is. Awesome. X equals 51, and I'm done. Okay, again, the biggest thing that you have to know is how to use your properties. How to rewrite as an exponential. How to use your change of base. Quotient, product, power. If you got a good grip on all those, it's going to be really easy to get x by itself. You're just pulling those tricks over and over and over and over. And yet a different type of example. I have a log, I have another log, and another log. I don't have log of something equals log of something else. However, I do have a log minus a log. Remember, minus log is our quotient rule. So I can say that this is the log of the first, so x minus 3 over log of the second, equals, I didn't change the other side at all, so it's still 3x minus 1. Well, now that I have log of something equals log of something else, then, go away. Nobody wants to see you. then really the insides have to be equal to each other. So that I would have x minus 2 over 2 equals 3x minus 1. And then it's just solving for x like you guys know how. I've gotten rid of all the logs, all the hard stuff's gone away. So if I multiply by 2 on both sides, remember to multiply the entire side by 2, that makes 1. So that I have x minus 2 equals 6x minus 2. And then I can do what? Minus x, add 2, plus 2, so 0 equals 5x. So therefore, x is 0. That's it. I have solved for it. However, this is not a real solution. What? Not a real solution? Okay. Every now and then, you're going to have to check for extraneous solutions. Think back to your log graph. When we graphed this thing, it never went negative. So since it never went negative, I cannot actually take the log of a negative number. I cannot have a negative number inside of there. Because x never goes negative. It's never on that side of the graph. I never have a negative x. So if I plug this 0 into any of my logs in the beginning, you have to look at the absolute beginning. If I put in a 0 right there, then I'm trying to take the log of negative 3, which doesn't exist. Since that doesn't exist, no solution. I cannot have any solution to this problem. If it would have worked in all of these, if I could have been finding a log of a positive number, then we're good to go. Okay, make sure you guys are checking for extraneous solutions. That's really the weird thing about this section. Alright, this is the last type of problem that I'm going to look at in this video. Make sure you guys come in before or after school anytime. Ask me questions, ask your friends questions, Skype, FaceTime, Facebook, face message, face. Okay, do whatever you got to do to get your business taken care of. You guys are smart. I believe in every single one of you. Okay, in this case, I have two logs again, equals something without a log. Well, I know that log plus a log is my product rule, so I can say it's the insides multiplied together, which is log base 2 of x minus 2 times x plus 2 equals 5. And look, I can just multiply these insides together so that I have a difference of squares, which is log base 2 of x squared minus 4 equals 5. And then using my rewriting as an exponential, I can say 2 to the fifth equals the thing inside x squared minus 4. 2 to the fifth is 32, so I have 32 equals x squared minus 4. Add 4, so x squared equals 36. And then when I take the square root, x equals plus or minus 6. Now again, just like in the last one, you got to go back and check for extraneous solutions. This positive 6 is probably good because it looks like it's big enough, because if I had 6 minus 2, that's 4. 6 plus 2 inside that log works. So I know that positive 6 works. But what about negative 6? If I put in negative 6 over here, I have negative 6 minus 2. So I would be trying to take the log of negative 8, which is impossible because it doesn't exist. It's not even a part of your graph. If we have our log graph, if I try to take the log of negative 8, well, negative 8 is 1, 2, 3, 4, 5, 6, 7, 8. It's all the way over there somewhere. It doesn't even have anything on your graph, right? The range of this, or domain, is from 0 to infinity. I can take anything from 0 to infinity in my x's, except for 0. Well, I guess I can't take 0. 0 is undefined, and anything less than 0 is undefined. So if you find that you're taking a log of anything 0 or less, it is not a real solution. So really, the only solution that we have is positive 6. Even though we came out with 2 answers, we only have one real solution. I know you guys are going to have questions about this video. Write them down now while you still have them on your mind. Come ask me. I promise I'll answer them. Although I don't have you guys sitting right here. I mean, I'm in a room by myself, and if anybody looked through the window, they think I'd ask absolutely crazy, because I'm just talking to a room full of no kids and telling them how to work problems. Students of years past come back to haunt me. Nah, I'm not that old yet. Alright, you guys have a good night. Hopefully this video helped. I will see you guys soon. Peace out, Cub Scout.